Hey, college algebra. Try not to be too sad, okay? But these are the last videos of the year that you're going to have to watch. This is our last new content. Okay, after this, we just have review for the final. And then our final exam will be next Thursday. Okay, I forget the date, 11th, I think. Okay, but next Thursday. Well, since we're going to be in tier 1 by then, we'll all be together. All the A's and B's will be taking the final at the same time. So that's kind of good. All right, so this is the last new content. We have to finish up chapter 6. You guys did a great job over break with 6-1. And now we're just going to finish out the rest of this chapter on matrices. Okay, so just a little recap. You see here, in general, we denote a matrix by its dimensions, okay, rows by columns. We use a capital letter, and the elements inside the matrix are denoted with the lowercase letters and the numbers of the row and column that they're associated with, okay? Then we have just some vocab about how we compare matrices. Two matrices are equal if they have the same size, which means the same dimensions, and the corresponding entries are equal. Okay, so right here we have a 2 by 1 equal to a 2 by 1 because the first row, first column element is the exact same as the first row, first column element in the second matrix. Okay, they have to have the same dimensions and their corresponding entries are equal. Note the word corresponding, okay? Not just the entries are equal, but the corresponding entries are equal. Let me show you with this example. Okay, take a second and think about whether or not you think these are equal. Are these equal or not, and why? Okay, before we move on, maybe pause me. All right, this first group, hey, this is a 2 by 2, and this is a 2 by 2. So they have the same dimensions, right? Then we look at each entry. And as soon as I look at the first row, first column entry and see that that's 4 in this matrix and 1 in this matrix, I can stop. I really don't care that the rest are equal. They all have to be equal, and these aren't, right? So these are not equal, and the reason is because the first row, first column element in matrix 1 does not equal the first row, first column element in the other matrix. All right. Now this one, I notice that the dimensions are not the same, right? This is a 1 row by 2 columns. This is 2 rows by 1 column. Yes, they have the same elements. The elements in this matrix are 3 and 5. The elements in this matrix are 3 and 5, but they're not the same dimensions. So these are not equal either. Be careful, okay? They have to satisfy both those conditions. Same dimensions, same elements, same corresponding elements. All right? So you'll be asked problems like this in your homework and on the final. Okay, remember, we're not having an assessment on chapter 6, but all of the concepts that we've learned in chapter 6 will be on the final. We just aren't having an actual chapter 6 test like we had, the other tests. Okay. All right. So determine the values of X, Y, and Z that make the following matrix equation true. All right. So I literally would just set up each, you want to make sure each corresponding entry is equal to the other one. So let me box those in black. X has to equal 1. Well, that was easy, right? Why can't they all be that easy? Okay, then we have, this is the next element, y minus 1. Okay, right? This is I should have checked the dimensions first, huh? But they are both 2 by 2s. It's kind of easy to see. They're both 2 by 2s. The first row, second column is y minus 1 in this matrix. And, why can't I get the red there? And it's 3 in this matrix. So y minus 1 has to equal 3. And then we just have a nice quick algebra 1 equation to solve, right? Y equals 4. So that wasn't bad. X equals 1, Y equals 4. The only thing left is Z. And so since Z is located in the second row, first column, and Z in the second row, first column here is 2, Z is going to have to equal 2. Okay, so and then I don't have to do anything else. I got the 7 and the 7. So if X is 1, Y is 4, and Z is 2, then these two matrices will be equal. Notice they call it a matrix equation because they're just setting one matrix equal to another. All right, we've done linear equations, quadratic equations, polynomial equations, exponential equations, logarithmic equations, and now you guys are doing matrix equations. Pretty cool. Okay, so let's try this next one. Here we have another 2 by 2. And this is a 2 by 2. Be careful. I've had students in the past say, no, that's a 2 by 3 because this Y plus 1, they take that as like 2 different columns, but they're not. Y plus 1 is one element. Okay, be careful. It's connected by addition. This is connected by subtraction. That's one element. Right, so be careful with that. Right? Take a second and try that, okay? Please pause me and do that on your own. Please, please, please. I want you to have a chance to try it yourself, okay? All right, hopefully you paused me, and let's see if you got the right answer. Obviously, X is going to equal 1. I hope you got that. And I'll circle it for you. Okay. The next one, let's go to the next column. 2 has to equal Y plus 1. So again, I have a little algebra to do to get that Y equals 1. Okay, great. Done with that. Let's go to our next column. Yep, 3 equals 3 every day of the week. So we don't have to do anything with that. But Z plus 1 has to equal 2Z minus 1. Right? So again, you can't forget anything in college algebra. Did you notice that? It's like everything just comes back. Now we solve, and hopefully you got Z to equal 2. Okay? Guys, if you have any questions on this, please come to my office hour on Wednesday. Sometimes, I mean, several of you do come, but I'd love to see more of you there. You can ask me, hey, it's your hour. Ask me anything you want. Okay, I just leave it open from 10 to 11. I know we only have, like if you're in period 1, you're supposed to come from 10 to 10:30, period 2, 10:30 to 11. But it's the same thing as college algebra. I don't care when you come. From 10 to 11, I'm open answering college algebra questions. Okay, so anyway, if you have trouble in the videos, please come. Okay, matrix addition. Oh, you're going to love this. Literally all you do is add corresponding parts. Is that beautiful? A plus B. I'm going to add the first row, first column is going to be the sum of the first row, first columns. -4 plus 7. That's all I have to be able to do. The second row, first column, I add 3 and -3. The second row, first column, I add 5 and 7. The second row, second column, I add -2 and -5. Okay, so that's the A plus B matrix. Right, so go ahead and try this one on your own. Again, pause me so that you have a chance. The beauty, you can control this. You can just pause me and do it and then check your answers, okay? Okay, hopefully this is what you got. You added the corresponding parts and got 8009. Now let's think back. I want you to draw these parallels. You know what additive identity is, right? The additive identity is 0. That's the number that we add to anything and get myself back. Additive inverse is what do I add to a number to get 0. So the additive inverse of 3 is -3. The additive inverse of -4 is +4, right? So they're opposites. Same thing with matrices here, okay? When we're going to be ask you to find the opposite of a matrix, because when you add two opposite matrices together, you get the zero matrix. Okay, so the opposite of this matrix, you just have to be careful and make sure that you change every single element to the opposite. Okay, so the opposite of A is going to be the opposite of 1, or of -1, the opposite of 2, the opposite of 0, the opposite of 4, the opposite of -3, the opposite of 5, the opposite of 2. See how you do that? Okay. So if I would take A plus -A, or yeah, A plus the opposite of A, I should say, then you definitely should get the zero matrix. Okay, same dimensions, but a matrix full of zeros. All right, go ahead and try this next one. All right, pause me for a sec. The opposite of A here will be -2, -3, 4, and -1. And I don't even have to, anytime I see this, what's A plus the opposite of A? You just make sure it has the same dimensions, but it's just all zeros. Hey, I don't think I stressed something. Let me go back here for a second. Notice matrix addition. The only way you can add this, add two matrices, is if they have the same dimensions. It's kind of hidden in here in the definition. The sum of two m by n matrices is the m by n matrix A plus B, whose entries are the sums of the corresponding entries of A and B. It's worth looking at that mathematical definition there, guys. Okay, that if you have two matrices that aren't the same dimensions, you can't add them together, because the way you get your answer is you add corresponding entries. You're not going to have corresponding entries if they're not the same dimensions. Okay, the reason I was showing you opposite is because that's how we subtract matrices. Okay, to subtract A minus B, and again, same dimensions, they have to be the same dimensions, you take A plus the opposite of B. Hey, it's worth doing that step, guys, because people, just like you know how you mess up distributing a negative through the parentheses, people mess this up too. I don't want you to miss these points on the final, okay? Because these are some points that are, pretty gettable. So really just subtracting. Okay, A minus B. First of all, if I'm going to do A minus B, they better be the same dimensions. Let's see, this is a 1 by 3. This is a 1 by 3. So you should be able to do that. I'm going to find the opposite of B, because that's how we subtract. We're going to take A plus the opposite of B. The opposite of B is -3, 1, -6. Now when I take A plus the opposite of B, I'm adding the corresponding entries. 3 plus -3 is 0. 5 plus 1 is 6. 8 plus -6 is 2. Okay, that's A plus -B. C minus D, this is a 3 by 1, and this is a 3 by 1, so I'm good. My answer will be a 3 by 1, but I'm going to find the opposite of D first so that I don't make any arithmetic errors. Take a second, find the opposite of D, and now I'm going to take C plus the opposite of D, just like we do when we add and subtract integers. So I have -3 plus -4, that's -7. 5 plus -7, that's -2. 6 plus -2 is 4. Okay? Then I try to do A minus C. I have a 1 by 3 and a 3 by 1. Nope, can't do it. Okay, no solution, can't do it. Does not exist. It'll say something like that, one of those words, okay? They're not the same dimensions, cannot add them. All right? Scalar multiplication is when you just multiply a number by the entire matrix, okay? I'm going to pause it and show you the answers because we're about out of time. This is my last slide, okay? All right, try it anyway. Guys, 15 seconds left. 3A, I took 3 times everything in A. -2B, I took -2 times everything in B. Okay, so look at those, make sure you got the right answers, and good luck on the homework, but make sure you watch the next video. Okay, bye.